Mirai DTL-332M100. Problem with it is I got no backlights. Look down here, just get the standby light. I can press this standby button and nothing really happens. You can see the standby light changing, but no backlights. I'm going to remove the back cover now and have a look and see what I can see. First thing I'm going to check is my 24 volt supply to my inverter board here. It gets its 24 volt supply from the power supply here. Comes out in these 3 pins here. There's 3 cables that carry that 24 volts down to the inverter PCB. The inverter PCB then upconverts that to a couple of thousand volts to drive these lamps. You see the 2 cables coming out here. There's 8 lamps in total inside the screen. First, let's just check this 24 volt supply. The unit is in standby at the moment. I'm going to press the standby button, and we have our 24 volts here on the power supply. What I have to do now is see, is it reaching the connector here on the let's see, can I get a better shot of that? The 24 volts from the power supply come in here on this connector here. I'm going to be careful here. And I have 24 volts there at that spot. I'm going to take this cover off this inverter board now and have a look at the inverter board itself. The unit is still plugged in, and I'm going to just check these 2 fuses here first, and I could do a diode check, but I'm going to just do a live check on it. What I should have is 24 volts on both of these, on both sides. When I take it out of standby, it's in standby at the moment. Out of standby, I'm getting 24 volts on that side. Got that side, and we have it here. So we have our 24 volt supply to the inverter section. So what I'm going to do now is check to see if I got drive to these VITs. I have my oscilloscope connected up and ready to test these VITs. I'm going to be monitoring this pin here on the VIT, and I'm going to now just change the camera angle so you can see the oscilloscope. I'm just going to take it out of standby now, and we have no drive. Because we have no drive to the VITs, I'm going to just check for voltage around this area here, because I believe the drive for the VITs come from this area. I don't have a schematic to be 100% sure, but I know there should be something on this regulator, and I have nothing there. Now we also have a little fuse here, F1, 0 volts on that side. And we have 24 volts on that side. So it's looking like that little fuse is open circuit. Those fuses I would imagine be available from little diode. They do a lot of fuses like that. The value of this fuse is yet I don't know. The only thing I can see on it here is 20. Maybe that stands for 2 amps. I can't be 100% sure. This is a partial schematic of the inverter board, and it's only covering the section for switching on the backlight and some of the protection that's available on it. And this here's the fuse F1 that was open circuit, and what I had to do was determine how much current was flowing through it. I did put a 500 milliamp circuit protector in that position, and had a look, but the inverter still would not work. What I then did was I went and done some checks on the actual inverter board, trying to figure out where the fault was. I had my 24 volts here at this point, and we do have a regulator here that should have 24 volts on this side and 5 volts on this side, and that 24 volts there was missing, and that there is controlled by the backlight on signal coming from the signal board. Normally you see the backlight BLON, that's what it says on the inverter board, and that would come in here to this comparator here, an LM339. I was pressing the standby button, that was going high, and the output here was changing as well. Comes out here on pin 1, and it goes to the base of this transistor here, Q23, and then that Q23 then should drive this R1, this Q1 here, which then switches on this Q12. A long way around doing it. And what I found from my checks was, even though it was going from high to low here at pin 1 of the U2, that's the circuit reference number for that IC, it was not changing on the base of Q12, which would be switching on this 24 volt supply. These are all surface mounted transistors, and the markings are very hard to make out. But in the end, I found, let me just make sure I got my circuit reference number right. Q1, which is this transistor here, that was shorted. What I found was that Q1 was short circuit, and it was bringing that point low all the time, so this transistor was not switching on. All the transistors I've shown in this are all N-type, but I didn't go down the route of trying to figure out whether P-type or N-type. I just put in a transistor for speed. So don't, when you're looking at this diagram, don't mind whether it's an NPN type or a PNP type. And what I found was then I had a similar inverter board for a 40-inch, and by measuring the transistor on that, I found out that it was an N-type. I don't know what, it just did not show me any markings on it to be able to determine what type of transistor it was. But I did have some BC846s, which is silicon N-type transistor in stock, and I put that in its place. And then when put that in its place, now I had my 24 volts here and this 5 volts here, and I then used my meter across this point here, between them 2 points there, and I found there was about 30 milliamps of draw in that circuit. I'm going to have to put in at least if I can, 100 milliamps. I don't think I'd get any lower than that, but I think I have 200 milliamp fuses here in stock. So what I'll do is I'll put a 200 milliamp fuse in there. We should be adequate for most circumstances. This also has the protection going into it that will shut it down as well, but because the fault wasn't in there, I didn't throw out the full schematic. I might complete this series. Okay, let's go back to the unit now and show how I've done the measurement of the current. Right now the unit is on standby, and it's plugged in, and the fuse, there's no fuse in this position here. Now what I'm going to do is I'm going to put my meter set to the DC amp mode, and I'm going to just put 2 leads across that like so, between them 2 points there. I don't know if you're getting it or not. And then I'm going to switch on and measure the current going through it. This here is that transistor that I replaced. Just see, get my hand out of the way. That transistor is the one I replaced there. That's Q1. Sorry, yes, Q1. Okay, I'm going to put the meter on now. I'm going to just let you have a look. And we're on the 10 amp range. I'm switching it on. There's no backlight at the moment because there's no fuse in its place. But what I'm going to do is I'm just going to put this meter across it, and we're reading 0.03. That's 30 milliamps we have. So I'm going to have to get a low current fuse and stick it in there. The inverter is back up working now, and you can see here by the light that's shining through the back of the metal housing of the screen. What I'm going to do is I'm going to check the drive voltages on these VITs. Let's see, can we get them into a shot? I'm just going to check the base of this VIT here. It would be the same on them all. If we went along them all, it would be the same. Should be the same drive waveform on them all. Actually, some of them are reading. I'll get you a shot of the oscilloscope. I'm just going to do a few waveforms on the inverter board. My scope is set to 2 volts per square per division, and I'm set to 20 microseconds per square as well, and I'm set roughly down to about 0 volts at the moment. And what I found is you got 2 VITs per lamp, and what you have is it alternates between this waveform these 2 different waveforms. That's 2, 4, 6 volts peak to peak, and this one here is also 6 volts peak to peak, but it's sitting up higher. It's sitting at 1, 2, 3, 4, say about 6 volts. All it remains now for me to do now is put it back together again and have a look at the picture quality in it. Unit is plugged in and ready to go. It's all back together. I'm going to just press the standby button. Backlights are up working. Blue screen. It's auto detected now. See what's plugged into it. I have an HDMI source in the back. And there we are. We have a picture. That inverter board is found in many models of LCD TV, and it's not just relevant to this Mirai brand. The numbers that you would find on the actual inverter board is VIT70002.60, and then you also have underneath that I320B1-24-V04. I hope that's of some help to someone out there. Thanks for watching.